Hello, this lesson is section 5.1 as we talked about the angles in a polygon. And we're going to talk about interior angles. Now, we've talked about interior angles before, right? So, the sum of the interior angles of a polygon. So, what is the sum of the interior angles of a triangle? You should know that immediately, right? I know, you totally knew. 180 degrees. But what about a quadrilateral? Now, when I say quadrilateral, that doesn't mean rectangle, square. It means all of them, right? Trapezoid, parallelograms, any kind of quadrilateral. Right? What is the sum? Now, I think many of you may know it is 360. So why? When you went up to a triangle to a quadrilateral, why is it 360? What happens if we go to a pentagon and then a hexagon? Do you remember seven-sided? Heptagon, octagon, nonagon, decagon, undecagon, dodecagon. How do we find those? All right. Well, let's go back to inductive reasoning. Because we know about a triangle and quadrilateral, maybe we can figure out for the other ones. Okay. So let's look here. I have a nice table. This is the number of sides, Rn. Note that there's no 1 or 2. Why isn't there 1 or 2 for polygon? That's right, because you can't make a polygon with 1 side or 2 sides. So we start with 3. And then here on the bottom will be the sum of the measures of the angles. Okay, so let's complete it. So we said the triangle is 180 and the quadrilateral is 360. So, but why is it again? The quadrilateral is 360. Okay, I hear you. So if I draw a diagonal, saying I could have 2 triangles. So the sum of this one is 180 and the sum of this one's 180. So if you add up all those angles all together, that would be 360. Okay, so let's take that idea and then move that over to pentagon. So if I take one vertex and I draw this, okay, how many triangles can I make? Well, that's this time 3. So I have 3 triangles. So this is going to be 180. That's 180. And then this is also 180. So that's 3 times 180. That turns out to be, okay, I think that's 540. Now we're in degrees. Okay, well, what about 6? So why don't you take a moment, pause, try to figure that out, complete the table, see if you can come up with the nth term. And when you're done, unpause. 180. So how many triangles? 4 triangles times 180. What is that going to be? 720. So I'm going to take, now could I do it to any? Sure. Vertex? Yeah. Just draw the diagonals, 1 vertex. So I have 180. I don't know if I need to write 180 every time. But how many triangles do I have? 1, 2, 3, 4, 5. Okay, 5 times 180. Okay, now I'm going to bust out my calculator. Times 5. 900 degrees. Okay, so what are we doing? So we are adding 180 each time. Okay, because we're adding, and why is that? Because we're adding, that's right, 1 triangle each time. So did you figure out an nth term for it? So if I'm looking here, I have 180, 180, 180. So can I rewrite that? Well, that's 180 times 2, right? Because we had 2 triangles. And then this was 180 times 1, it's 1 triangle. So if I'm looking through here, what do we notice? What's the same? You're right, 180 is the same for all of them. So my formula, my expression, my nth term must have 180. Now what's the thing that changes? It's this number, 1, 2, 3, 4, 5. Well, What is that? Well, it's not n because n is 3, but how do you get from 3 to 1? How are you going from 4 to 2? How are you getting 5 to 3, 6 to 4, 7 to 5? You're subtracting 2. And is it consistent all the way? Yes. So it's n minus 2. Yes, you need the parentheses around the whole thing because you have to subtract first, then multiply from 180. So that is our nth term. Okay. So let's write it as a theorem. The sum of the measures of the n interior angles, okay, for the n-gon polygon is, what's the formula? N minus 2 equals, times 180. Now remember, this is the sum of the measures of a polygon. You have to remember. I'm going to just abbreviate it. Angles of a polygon, okay? Always remember what your equations are for, so you don't mix them up in your head. Okay, remember n represents the number of sides of your polygon. It's also important to know what your variables represent, so you're putting in the right thing. Okay. All right, so find the sum of the interior angles of the convex polygon, decagon. Okay, so you want to pause this, try this on your own. So a decagon, you need to know what the n. So the n equals 10. So the sum is going to equal 10 minus 2 times 180. So that's 8 times 180. Hand it in the calculator, that it is. 1440, don't forget degrees. Okay, 15 gon. So when they talk about n-gon, remember after 12, we don't have a special name. We just say n-gon. So this is a 15-sided polygon. So the sum is going to be 15 minus 2 times 180. So that's 13 times 180. Two, 3, 4, 0. There you go. They're like easy. Yep. All right, try these. Now these are picture ones, so you have to figure out a little bit different. So again, what do I see? You know, that's my first question generally. So I see that it's a quadrilateral, so that's 4. And so I know that the sum of it is going to be 180. I mean, sorry. Getting ahead of myself. N is 4. The sum is 360. Okay. That means if I'm only finding one, if I add them all together, the other 3, and subtract from 360, that will be, should be able to get A. So I'm adding all 3. Now, you can write an equation if you want to. You don't necessarily have to. So when you add them all together, right? And when you subtract from 360, that's actually what you're doing on here, right? And I have 132 degrees. Perfect. So that's going to be very similar to this next one. So you have to figure how many sides. Let's count. 1, 2, 3, 4, 5, 6. So n equals, that's right. What's the name of this? Hexagon. Now I'm going to say this is 90. So I'm going to add all of those together. So I have 90 plus 120 plus 130 plus 140 plus 80. So altogether I have 560 plus x equals, how much do they do? Oh, I forgot. Forgot to do that part. So it is, okay. I think I remember it was 720. Okay, so I'm going to say this is 720. I'm going to subtract, and it looks like 160. Just going to double check because I can. Yeah. And it's a good habit to double check. All right, so let's go backwards. How many sides? Okay, read the directions, underline, really think about it. This is where kids rush. How many sides of a polygon does a polygon have if the sum is this? So, do you see sum is? So, remember sides is n. So, remember how I told you write sum equals n minus 2 equals 180. So, when you see this, we say the sum, right, is, which is equal 120. So the sum is where? The sum's on this side. Oh, so that's where you're going to put the 6120. And then you just do the algebra. Now you should know that this is the multiplication, so that's the one you have to undo first. You can distribute it if you want to, or you can just divide the 180. It's really up to you. It's more than one way to solve equations. Again, as long as you have the correct reason and you know why. Okay. So, how many sides does it have? It has 36 sides. Write your unit when you can. Right, there you are. So, let's talk about this definition. People have forgotten this definition. What does regular polygon mean? Regular just doesn't mean, oh, just a nice one, or a pretty one, or just the normal one. No, it has a specific definition. If you don't know it, I need you to find it in your notes immediately. You're like, but Miss Vanessa, you're going to tell me. Probably. But you have to be able to find it later when I'm not there to tell you. Or I can't tell you. Regular polygon. Polygon with all congruent sides and congruent angles. So it's very specific. All the angles are congruent. Okay. So because of that, how would you find the interior of, oh, that is not a complete thing. How would you find one interior angle of a regular hexagon? I forgot the word regular. And this one. That really changes it. Because without that, you don't know. Well, I remember a hexagon, right, was 4 times 180 and minus 2. That was 720. Well, if all the angles are equal, then, right, then what do? Right? We can divide by 6. That's correct. So each one is going to be 120. What about a regular decagon? Well, first we find all of them. So n equals 10. So 10 minus 2 times 180. And then we're going to divide by, that's right, n, by how many you have. Divide by n, right? Number of sides. Okay, so 10 times 180. I have 144 degrees. Okay. And hopefully most of you were able to reason that out before I even said it. All right, so take a moment, try this one now. Again, what you see. I'll give you a moment. Or pause. All right, so we're looking for an exterior angle, one exterior angle. So if I can find this angle, and because the interior and exterior are linear, I can definitely find x. So let's see how many sides. I always have to put a mark here. Okay, so I can count. 1, 2, 3, 4, 5, 6, 7. Ooh. Do you remember what that's called? Heptagon. So We're going to find 1 first. So we're doing 7 times 180, and we're going to divide it by 7. This time I'm just going to put in my calculator. Now be careful when you put in your calculator. Then you're like, Miss Mendoza, it gives me a crazy wonky number. Yes, it does. All right. So because it does that, I'm going to double check it that it looks good. So can it be a decimal? Of course. So I'm going to round it to 3 decimal places. And you're going to be like, do I really need to? Yes. Don't argue with me. Yes. And then I'm going to subtract it. The more decimals, the more accurate. Because the moment you round, you become less accurate. So you want more decimals. Now, unless it says a specific thing, do 3. The reason why, I know it may be silly to you because you're so far away from it, in calculus, 3 decimals. Generally in physics, 3 decimals. So I'd like to teach you now about the whole 3 decimals. There you are. All right. Until next time, class, be safe, be well. Bye.